All right, this video we're going to talk about heritability as well as molecular genetics. So first of all, heritability is the extent to which a particular variation among people can be attributed to the difference in genes. That's like the textbook definition. The big thing that you have to understand with heritability is that we are talking about why there is a difference between a group of people. Why is it that, for example, we have a difference of, these groups of people, these people are all tall, and then we have a bunch of people that are all short, and then we have medium height people. Why is there a difference in, for example, people's heights? Why is it some people, for example, develop depression and others do not? Why do some develop schizophrenia and others do not? Okay, heritability is looking at the differences between people, and so as a result, why is that a result of genes? Okay, so for example, if I wanted to talk about let's say I have a group of people, and I'm just going to draw some lines here to represent my people. We're going to talk about height. Let's say that, just because it's nice and easy and simple. So each line is represent how tall some people are in this group, right? And so we have some people that are really short, some people are really tall. And so what we're talking about with heritability is we're talking about how much is their differences in height in these people, how much of that is a result of genes, okay? So for example, height is typically around 50% heritability. What we mean by that is that the reason for, okay, so the reason for the differences in height in here, 50% of that reason is because of genes. So the other 50% is a result of the environment, right? So we're looking at the reason why there's this differences between people. So, for example, when we talk about people, we could talk about this group of people, and maybe we're talking about this group of people being, let's say they're all middle class, and this is hard to write like this. Let's say that they're all middle class, white Americans. Okay. When they're all middle-class white Americans, I can say that the heritability is probably going to go up. Because, think about this, white middle-class Americans, okay, are all going to have a very similar environment that they grew up in. Okay, so we said that it's either, basically genetics or environment that's going to cause, for example, the differences in height. Okay, since there's a very similar environment that they're growing up in, any differences between them, for example, my, line people here, the differences between them are going to be mostly a result of genetics then, because they all are growing up in a very similar environment. However, let's say that instead of white middle-class Americans, let's just say we're just talking about Americans as a whole. Let's say we're talking about Americans as a whole. And this group of people represents Americans as a whole. We could obviously we'd have a lot more line people there, okay? But what happens is that Americans as a whole have a very wide range of environmental things that are going on. And obviously we could talk about, it's not a wide range of it, as wide of a environmental, than as compared to, like, for example, the entire world. But for, even within the United States, we have poor people, we have rich people, we have middle class people, we have lots of different ethnicities, and lots of different scenarios of what you grow up in and what your environment is in. Well, when we have a very wide range of environmental factors that is going on with my group of people here, the heritability is going to go down. Okay, because what happens is that there's going to be a lot of their differences are going to be more a result of their environment rather than a result of their genes. Okay, hopefully that helps and makes some sense. But what I do want to emphasize is that your percentage of heritability does not mean, I want to emphasize what it does not mean. It does not mean how much your characteristic is genetic. It does not mean, for example, my height is a result of, 50% of my height is a result of genes. But and I don't mean the jeans you wear. That doesn't make any sense, okay? We're talking about the differences between people are genetic. How much of that is genetic, okay? And I want to emphasize that because this is a concept that a lot of people struggle with in AP Psychology as a whole, and I can also say that there is a very good chance that this will show up on the AP test, at least one question, because people get confused on it. So a couple of examples, depression for one is 40% heritability, and I believe the information I got this from is looking at like worldwide 40% heritability. Alcoholism addiction is 50 to 60% heritability, so that has more to do with genes worldwide than environmental factors, but there obviously are some environmental factors that will add to that. And then also keep in mind that genes and environment do work together. So whatever your genes did give you, okay, your physical attributes as well as your personality and things, they work together because whatever you got genetically also influences how people see you and how people treat you, right? So I got a couple of examples of this. This is Melissa McCarthy. Melissa McCarthy is obviously a famous actress. She is known for not only her movie roles, but also her TV roles, but she's very well known for her comedy, right? She's a comedic actress. Whereas, for example, Sandra Bullock is also an actress, but she's kind of got a wider range of things that she's known for, types of movies, right? She's been in comedies, yes, but she's also been in rom-coms, some romantic comedies. She's also been in some more dramatic roles. But the thing that I'm trying to point out between these two lovely actresses, whether you like them or not, is that what their genes actually gave them influences how people see them. Okay? Would Sandra Bullock, for example, be offered romantic comedy or serious roles if she was not, if she didn't look the way she does, if she's not as physically attractive, right? Melissa McCarthy, physically attractive by herself, but at the same point in time, she's not in romantic comedies, for example. Right? So she's not in a lot of dramatic roles. Is that a result of her personal choice? I don't know. Is this a result of, because, she's obviously a very funny person, so, is she offered and she do mostly funny movies because, that's what she's learned people like about her and what they do, okay? So people respond to basically kind of what you put out there, basically. All right. And then lastly in this video, I wanted to talk about molecular genetics. And obviously, as you can tell, that I do have two very short video clips to go along with it. So molecular genetics as a whole is the study of our molecular structure and our function of our genes. And so basically what molecular geneticists do is that they do a lot of gene mapping. And so remember the gene is the smallest part of our chromosomes. So we have chromosomes and we have DNA and then we have genes, right? So we can talk about what we get from our parents, right? And molecular genetics is looking at basically the can we map the gene and can we find out is there a gene for a particular disorder or not? So I've got two clips for you. The first one is from a fictional movie called Gattaca. It is a movie that is actually out there. I have seen it. It's been a very long time, but this is a very kind of science fiction-y movie. So this is kind of the beginning, and I'll play this here for you.
Conceived in the Riviera, not the French Riviera, the Detroit variety. They used to say that a child conceived in love has a greater chance of happiness. They don't say that anymore. I'll never understand what possessed my mother to put her faith in God's hands rather than those of her local geneticist. 10 fingers, 10 toes, that's all that used to matter. Not now. Now, only seconds old, the exact time and cause of my death was is already known.
Neurological condition, 60% probability. Manic depression, 42% probability. Attention deficit disorder, 89% probability. Heart disorder, 99% probability. Early fatal potential. Life expectancy, 30.2 years.
30 years.
The name for the certificate? Anton?
No, Vincent Anton. It's a good name.
I know, do something. Do something. Vincent?
From an early age, I came to think of myself as others thought of me.
Vincent?
Chronically ill. Every skinned knee and runny nose was treated as if it were life-threatening.
I'm sorry, the insurance won't cover it. If he fell...
But I was told that everything was...
I really wish there was something I could do.
Like most other parents of their day, they were determined that their next child would be brought into the world in what has become the natural way.
Your extracted eggs, Marie, have been fertilized with Antonio's sperm. After screening, we are left, as you see, with 2 healthy boys and 2 very healthy girls. Naturally, no critical predispositions to any major inheritable diseases. All that remains is to select the most compatible candidate. First, we may as well decide on gender. Have you given it any thought?
We would want Vincent to have a brother, to play with.
Of course you would. Hello, Vincent. You have specified hazel eyes, dark hair, and fair skin. I have taken the liberty of eradicating any potentially prejudicial conditions, premature baldness, myopia, alcoholism, and addictive susceptibility, propensity for violence, obesity, etc.
We didn't want... diseases, yes, but...
Right. We were just wondering if it's good to just leave a few things to chance.
We want to give your child the best possible start. Believe me, we have enough imperfection built in already. Your child doesn't need any additional burdens. And keep in mind, this child is still you. Simply the best of you. You could conceive naturally 1,000 times and never get such a result.
That's how my brother Anton came into the world. A son my father considered worthy of his name.
Okay, so that's Gattaca. That obviously, like I said, science fiction movie. You can watch the whole thing if you'd like, but you get the idea of, they're basically in the future basically picking out their traits for their babies. So the other clip I have is a news clip about a company called 23andMe, and this is real.
Here's what we were thinking. What if you could get a mortgage on your phone? Wouldn't more people buy homes? And wouldn't those people need to fill their homes with household goods? And wouldn't the makers of those goods have phones from which they could easily secure mortgages of their own? Further stoking demand as our tidal wave of ownership floods the country with new homeowners who now must own other things. Anyway, that's what we were thinking.
Did you just feel the world get spookier? Oh, it's because 23andMe just got a patent on designer babies. Anthony here for T-News, and depending on who you talk to, designer genetics are the future. You get to pick and choose the best possible traits for your child. And it sounds wonderful, but there's a great deal of debate about the ethical concerns behind designer babies. Who would own the technology? What happens to people who can't afford to make their baby as perfect as other families can? Well, it's caused so much of a stir that it's already been made illegal in the UK and Canada. And last week, 23andMe was awarded a patent for something called the Family Traits Inheritance Calculator. If you're unfamiliar, 23andMe is a service that will sequence your genome and then let you know about your DNA, from potential health issues to your ancestry to stuff like, will cilantro taste like soap to you? Because there's a gene for that. Now, the calculator is a feature on their site that lets you and any other member see what traits their hypothetical child might have. How likely would it be to have your blue eyes or my dark hair? It's fun, right? it's just goofs, but there's some other stuff in the patent as well. Stuff they felt they needed to address on their blog that has science news outlets like Nature feeling just a little creeped out. See, there's another thing the traits calculator could do that's outlined in the application. A figure shows the system being used in concert with in vitro fertilization clinics. The prospective mother gives her DNA, the DNA of potential donors is analyzed, and then you get a friendly little screen with a drop-down menu that lets you say things like, I want a baby with high probability of green eyes, or I would like the baby to have the longest possible lifespan, or a slightly shorter lifespan but less chance of serious illness. So you fill out the quiz, the computer picks the appropriate donor, and boom, you have your perfect baby. 23andMe states on their blog that they have no intention of pursuing the technology that far, but that doesn't mean they won't. They could take it even further. And even if they don't, they could use the patent to potentially block anyone else from developing something similar. And this is not the first time 23andMe has gotten a potentially spooky patent. Last year, they announced a patent on a particular genetic mutation that might be beneficial to treating Parkinson's, stating that it was a protective measure to keep other organizations from doing the same. The press and the company's customer base came out against the patent, stating that 23andMe had never told customers that their genetic data could be used commercially. Now, there is something to be said for protective patenting. Something like the Parkinson's patent could keep it out of the hands of large pharmaceutical companies, but there's no guarantee that 23andMe will be any more open or generous with their findings. I would hate for potential progress to be halted by one company, or pushed too quickly by one. What do you think about the potential implications of 23andMe's new patent, or designer genetics in general? How about Gattaca? I love Gattaca. Let us know down below and subscribe for more D News.
All right, so you get the idea. So the Gattaca clip is mostly kind of showing you, in the future what it could be, and the D News is looking more at, what it is currently. So I did have people discuss in their group these 5 questions. They weren't things that I actually had them write down. I just had them discuss, and we kind of talked about it as a whole. But it's something to think about. Would you want to know? Would you want to know for yourself? Would you want to know for a potential child in the future? Kind of interesting stuff. So that's it for now. Let me know if you have any questions.